Monsoon is traditionally defined as a seasonal reversing wind accompanied by corresponding changes in precipitation, but is now used to describe seasonal changes in atmospheric circulation and precipitation associated with the asymmetric heating of land and sea. Usually, the term monsoon is used to refer to the rainy phase of a seasonally changing pattern, although technically there is also a dry phase. The major monsoon systems of the world consist of the West African and Asia-Australian monsoons. The inclusion of the North and South American monsoons within complete wind reversal has been debated. The term was first used in English in British India and neighbouring countries to refer to the big seasonal winds blowing from the Bay of Bengal and Arabian Sea in the southwest, bringing heavy rainfall to the area. The southwest monsoon winds are called Nairutia Maharut in India. Etymology. The English monsoon came from Portuguese mona picavolt poundo, ultimately from Arabic morsum, perhaps partly via early modern Dutch monsoon. History. Strengthening of the Asian monsoon has been linked to the uplift of the Tibetan Plateau after the collision of the Indian subcontinent and Asia around 50 million years ago. Because of the studies of records from the Arabian Sea and that of the wind-blown dust in the Loess Plateau of China, many geologists believe the monsoon first became strong around 8 million years ago. More recently, studies of plant fossils in China and new long-duration sediment records from the South China Sea led to a timing of the monsoon beginning 15–20 million years ago and linked to early Tibetan uplift. Testing of this hypothesis awaits deep ocean sampling by the Integrated Ocean Drilling Program. The monsoon has varied significantly in strength since this time, largely linked to global climate change, especially the cycle of the Pleistocene ice ages. A study of marine plankton suggested that the Indian monsoon strengthened around 5 million years ago. Then, during ice periods, the sea level fell and the Indonesian seaway closed. When this happened, cold waters in the Pacific were impeded from flowing into the Indian Ocean. It is believed that the resulting increase in sea surface temperatures in the Indian Ocean increased the intensity of monsoons. 5 episodes during the Quaternary at 2.22 Ma, 1.83 Ma, 0.68 Ma, 0.45 Ma and 0.04 Ma were identified, which showed a weakening of Liane current. The weakening of the LC would have an effect on the sea surface temperature field in the Indian Ocean, as the Indonesian through flow generally warms the Indian Ocean. Thus these 5 intervals could probably be those of considerable lowering of SST in the Indian Ocean and would have influenced Indian monsoon intensity. During the weak LC, there is the possibility of reduced intensity of the Indian winter monsoon and strong summer monsoon, because of change in the Indian Ocean dipole due to reduction in net heat input to the Indian Ocean through the Indonesian through flow. Thus a better understanding of the possible links between El Niño ±0, Western Pacific warm pool, Indonesian through flow, wind pattern off Western Australia, and ice volume expansion and contraction can be obtained by studying the behavior of the LC during Quaternary at close stratigraphic intervals. Strength of impact. The impact of monsoon on the local weather is different from place to place. In some places there is just a likelihood of having a little more or less rain. In other places, quasi-semi-deserts are turned into vivid green grasslands where all sorts of plants and crops can prosper. The Indian monsoon turns large parts of India from a kind of semi-desert into green lands. See photos only taken 3 months apart in the Western Ghats. In places like this it is crucial for farmers to have the right timing for putting the seeds on the fields, as it is essential to use all the rain that is available for growing crops. Process. Monsoons are large-scale sea breezes which occur when the temperature on land is significantly warmer or cooler than the temperature of the ocean. These temperature imbalances happen because oceans and land absorb heat in different ways. Over oceans, the air temperature remains relatively stable for 2 reasons. Water has a relatively high heat capacity, and because both conduction and convection will equilibrate a hot or cold surface with deeper water. In contrast, dirt, sand, and rocks have lower heat capacities, and they can only transmit heat into the earth by conduction and not by convection. Therefore, bodies of water stay at a more even temperature, while land temperature are more variable. During warmer months sunlight heats the surfaces of both land and oceans, but land temperatures rise more quickly. As the land surface becomes warmer, the air above it expands and an area of low pressure develops. Meanwhile, the ocean remains at a lower temperature than the land, and the air above it retains a higher pressure. This difference in pressure causes sea breezes to blow from the ocean to the land, bringing moist air inland. This moist air rises to a higher altitude over land and then it flows back toward the ocean. However, when the air rises, and while it is still over the land, the air cools. This decreases the air's ability to hold water, and this causes precipitation over the land. This is why summer monsoons cause so much rain over land. In the colder months, the cycle is reversed. Then the land cools faster than the oceans and the air over the land has higher pressure than air over the ocean. This causes the air over the land to flow to the ocean. When humid air rises over the ocean, it cools, and this causes precipitation over the oceans. Most summer monsoons have a dominant westerly component and a strong tendency to ascend and produce copious amounts of rain. The intensity and duration, however, are not uniform from year to year. Winter monsoons, by contrast, have a dominant easterly component and a strong tendency to diverge, subside and cause drought. Similar rainfall is caused when moist ocean air is lifted upwards by mountains, surface heating, convergence at the surface, divergence aloft, or from storm-produced outflows at the surface. However the lifting occurs, the air cools due to expansion in lower pressure, and this produces condensation. Global monsoons, Africa. The monsoon of western sub-Saharan Africa is the result of the seasonal shifts of the intertropical convergence zone and the great seasonal temperature and humidity differences between the Sahara and the equatorial Atlantic Ocean. It migrates northward from the equatorial Atlantic in February, reaches western Africa on or near June 22, then moves back to the south by October. The dry, northeasterly trade winds, and their more extreme form, the harmattan, are interrupted by the northern shift in the ITCZ and resultant southerly, rain-bearing winds during the summer. The semi-arid Sahel and Sudan depend upon this pattern for most of their precipitation. North America. The North American monsoon occurs from late June or early July into September, originating over Mexico and spreading into the southwest United States by mid-July. It affects Mexico along the Sierra Madre Occidental as well as Arizona, New Mexico, Nevada, Utah, Colorado, West Texas and California. It pushes as far west as the Peninsula Ranges and transverse ranges of Southern California, but rarely reaches the coastal strip. The North American monsoon is known to many as the summer, Southwest, Mexican or Arizona monsoon. It is also sometimes called the desert monsoon as a large part of the affected area are the Mojave and Sonoran deserts. Asia. The Asian monsoons may be classified into a few subsystems, such as the South Asian monsoon which affects the Indian subcontinent and surrounding regions, and the East Asian monsoon which affects southern China, Korea and parts of Japan. South Asian monsoon. Southwest monsoon. The southwestern summer monsoons occur from July through September. The Thar Desert and adjoining areas of the northern and central Indian subcontinent heats up considerably during the hot summers. This causes a low-pressure area over the northern and central Indian subcontinent. To fill this void, the moisture-laden winds from the Indian Ocean rush into the subcontinent. These winds, rich in moisture, are drawn towards the Himalayas. The Himalayas act like a high wall, blocking the winds from passing into Central Asia, and forcing them to rise. As the clouds rise their temperature drops and precipitation occurs. Some areas of the subcontinent receive up to 10,000 mm of rain annually. The southwest monsoon is generally expected to begin around the beginning of June and fade away by the end of September. The moisture-laden winds on reaching the southernmost point of the Indian Peninsula, due to its topography, become divided into two parts, the Arabian Sea branch and the Bay of Bengal branch. The Arabian Sea branch of the southwest monsoon first hits the western ends of the coastal state of Kerala, India, thus making this area the first state in India to receive rain from the southwest monsoon. This branch of the monsoon moves northwards along the Western Ghats with precipitation on coastal areas, west of the Western Ghats. The eastern areas of the Western Ghats do not receive much rain from this monsoon as the wind does not cross the Western Ghats. The Bay of Bengal branch of southwest monsoon flows over the Bay of Bengal heading towards northeast India and Bengal, picking up more moisture from the Bay of Bengal. The winds arrive at the eastern Himalayas with large amounts of rain. Monsoon, situated on the southern slopes of the Khasi Hills in Meghalaya, India, is one of the wettest places on Earth. After the arrival at the eastern Himalayas, the wind turns towards the west, travelling over the Indo-Gangetic Plain at a rate of roughly 1–2 weeks per state, pouring rain all along its way. June 1st is regarded as the date of onset of the monsoon in India, as indicated by the arrival of the monsoon in the southernmost state of Kerala. The monsoon accounts for 80% of the rainfall in India. Indian agriculture is heavily dependent on the rains, for growing crops especially like cotton, rice, oilseeds and coarse grains. A delay of a few days in the arrival of the monsoon can badly affect the economy, as evidenced in the numerous droughts in India in the 1990s. The monsoon is widely welcomed and appreciated by city dwellers as well, for it provides relief from the climax of summer heat in June. However, the roads take a battering every year. Often houses and streets are waterlogged and slums are flooded despite drainage systems. A lack of city infrastructure coupled with changing climate patterns causes severe economical loss including damage to property and loss of lives, as evidenced in the 2005 flooding in Mumbai that brought Mumbai to a standstill. Bangladesh and certain regions of India like Assam and West Bengal, also frequently experience heavy floods during this season. Recently, areas in India that used to receive scanty rainfall throughout the year, like the Thar Desert, have surprisingly ended up receiving floods due to the prolonged monsoon season. The influence of the southwest monsoon is felt as far north as in China's Xinjiang. It is estimated that about 70% of all precipitation in the central part of the Tian Shan Mountains falls during the 3 summer months, when the region is under the monsoon influence. About 70% of that is directly of cyclonic origin. Northeast monsoon. Around September, with the sun fast retreating south, the northern landmass of the Indian subcontinent begins to cool off rapidly. With this air pressure begins to build over northern India, the Indian Ocean and its surrounding atmosphere still holds its heat. This causes cold wind to sweep down from the Himalayas and Indo-Gangetic Plain towards the vast spans of the Indian Ocean south of the Deccan Peninsula. This is known as the northeast monsoon or retreating monsoon. While traveling towards the Indian Ocean, the dry cold wind picks up some moisture from the Bay of Bengal and pours it over peninsular India and parts of Sri Lanka. Cities like Chennai, which get less rain from the southwest monsoon, receives rain from this monsoon. About 50% to 60% of the rain received by the state of Tamil Nadu is from the northeast monsoon. In southern Asia, the northeastern monsoons take place from December to early March when the surface high-pressure system is strongest. The jet stream in this region splits into the southern subtropical jet and the polar jet. The subtropical flow directs northeasterly winds to blow across southern Asia, creating dry air streams which produce clear skies over India. Meanwhile, a low-pressure system develops over Southeast Asia and Australasia and winds are directed toward Australia known as a monsoon trough. East Asian monsoon. The East Asian monsoon affects large parts of Indochina, Philippines, China, Korea and Japan. It is characterized by a warm, rainy summer monsoon and a cold, dry winter monsoon. The rain occurs in a concentrated belt that stretches east-west except in East China where it is tilted east-northeast over Korea and Japan. The seasonal rain is known as Meiyu in China, Changma in Korea, and Baiyu in Japan, with the latter two resembling frontal rain. The onset of the summer monsoon is marked by a period of premonsoonal rain over South China and Taiwan in early May. From May through August, the summer monsoon shifts through a series of dry and rainy phases as the rain belt moves northward, beginning over Indochina and the South China Sea, to the Yangtze River Basin in Japan and finally to North China and Korea. When the monsoon ends in August, The rain belt moves back to South China. Australia. Also known as the Indo-Australian monsoon. The rainy season occurs from September to February and it is a major source of energy for the Hadley circulation during boreal winter. The maritime continent monsoon and the Australian monsoon may be considered to be the same system, the Indo-Australian monsoon. It is associated with the development of the Siberian high and the movement of the heating maxima from the northern hemisphere to the southern hemisphere. Northeasterly winds flow down Southeast Asia, are turned northwesterly-westerly by Borneo topography towards Australia. This forms a cyclonic circulation vortex over Borneo, which together with descending cold surges of winter air from higher latitudes, cause significant weather phenomena in the region. Examples are the formation of a rare low-latitude tropical storm in 2001, Tropical Storm Vamay, and the devastating flood of Jakarta in 2007. The onset of the monsoon over the maritime continent tends to follow the heating maxima down Vietnam and the Malay Peninsula, to Sumatra, Borneo and the Philippines, to Java, Sulawesi, Irian Jaya and northern Australia. However, the monsoon is not a simple response to heating but a more complex interaction topography, wind and sea, as demonstrated by its abrupt rather than gradual withdrawal from the region. The Australian monsoon occurs in the southern summer when the monsoon trough develops over northern Australia. Over 3/4 of annual rainfall in northern Australia falls during this time. Europe. The European monsoon is the result of a resurgence of westerly winds from the Atlantic, where they become loaded with wind and rain. These westerly winds are a common phenomenon during the European winter, but they ease as spring approaches in late March and through April and May. The winds pick up again in June, which is why this phenomenon is also referred to as the return of the westerlies. The rain usually arrives in two waves, at the beginning of June and again in mid to late June. The European monsoon is not a monsoon in the traditional sense in that it doesn't meet all the requirements to be classified as such. Instead, the return of the westerlies is more regarded as a conveyor belt that delivers a series of low-pressure centers to Western Europe where they create unsettled weather. These storms generally feature significantly lower than average temperatures, fierce rain or hail, thunder and strong winds. The return of the westerlies affects Europe's northern Atlantic coastline, more precisely Ireland, Great Britain, the Benelux countries, western Germany, northern France and parts of Scandinavia. References. Further reading, International Committee of the Third Workshop on Monsoons. The Global Monsoon System, Research and Forecast. Chang, C.P., Wang, Z., Hendon, H., 2006, The Asian Winter Monsoon. The Asian Monsoon, Wang, B., Praxis, Berlin, ppA 89A-127. External links, National Weather Service, The North American Monsoon, East Asian Monsoon Experiment, Influence of Monsoon Winds, Meet the Indian Monsoons at pbs.org, Arizona Central Monsoon Page, Basics of the Arizona Monsoon.